Okay, now that we've learned about alkanes, it's time to progress to alkenes and alkynes. And here's a model of what an alkene would look like, at least in this model kit. I want to point out a few things before we start with too many notes, okay? First of all, I can rotate this bond because it's a single bond without a problem. So whatever's on the sides here, they can move freely. But in an alkene or something with a double bond, I can't rotate that, okay? And as a matter of fact, in order to make this guy go up here, I have to actually remove atoms and put them up here. Or I would have to break these bonds in order to make a rotation happen, right? Well, that's why this is actually a different molecule. It's a different isomer than when we first started with the carbon down here. Okay? So another thing I want to point out is these carbons right here. They have three things that they're bonded to. Remember, we're trying to get as far away from each other as possible because, well, there's electrons in these bonds, right? So if this carbon's bound to three things, the furthest it can make those three things apart from each other is 1, 2, 3. They're all in the same plane. That's a trigonal planar arrangement for both of these carbons. Unfortunately, I don't think I can put together a triple bond with this particular model kit that I'm using. But if you have a triple bond, then a carbon is bound to another carbon 3 times, as well as a hydrogen or whatever it may be over on this side. And the easiest place to get two things apart from each other would be a simple line. And so that's the difference between an alkene and an alkyne. An alkene is something that has a double bond in it, and an alkyne is something that has a triple bond in it. So again, these are 120 degrees in this double bond. That's what those two lines between the two carbons mean, and that's why this goes 1, 2, 3, and it's flat. Okay. A triple bond is really a straight line, and so we tend to write things like this for a triple bond. Well, that can be confusing because this is a straight line here, but the place where it has the double bond, or the second bond up here and the third bond down here, that is actually a carbon right there. There's a carbon right there. There's a carbon right there, and a carbon right there, unless it tells you otherwise. So be careful when you're counting your number of carbons in a triple bond. This is just a line, again, so that's a line, okay? Now, the same way that I just showed you how to rotate those things, we're going to name those differently because they're not the same molecule. So when you have the two groups, whatever they are, if they're going in the same direction, we call that a cis isomer. So this right now would be in the cis isomer formation. Okay? And before, it's the trans isomer. So let me make that again for you. See how that's different? We now have a CH3 and a CH3 on the opposite sides of where that double bond is. That would be the trans isomer. So they're trans from one another. When we go to name alkenes, we have to tell people where the double bond is located. And we actually don't say it's located between like carbon 3 and 4. We just tell them that 3 is the lowest number for that, so we don't have to actually repeat the 4. So we would call something like 3, whatever it may be. Okay? So that's why we use the lowest number in the carbon chain possible for the alkene. Now this takes priority over what we learned last time, and I'll show you some examples of that in just a minute. We also have to tell people that it's cis or trans. That goes at the beginning of the name. We're going to also not end the alkene with an A-N-E, but instead we're going to end it with an E-N-E. That shows you that you actually have a double bond. When you're making cycloalkenes, we actually designate that the double bond is between the 1 and the 2, or whatever that may be. They are carbons 1 and 2 when we start to number them. And, you know, if there's a substituent, we want to obviously make that the lowest number possible as we go through this, okay? So let me give you some examples here. Oh, I'm sorry, let's name alkynes as well. So here, instead of ending the name in an A and E, we're going to end it in a Y and E, and we call that alkyne. So as with alkenes, you have to tell people where that triple bond is located, and you don't have to worry about cis-trans with alkynes, which is kind of awesome because it's all a line, right? Okay, so let's practice this. Right here, we have 1, 2, 3, 4, 5, 6. I start numbering on this direction because that's going to give my ene, or my double bond, the lowest number possible. So if I just write hexene, it's assumed to be between the first and the second carbon, but if you want to put a 1 there, that's completely fine. Same thing with cyclohexene, that's assumed to be between the first and the second. Ooh, that's not cyclohexene, is it? That's what happens when you make notes too much. Okay, so this would be cyclopentene because there are 5 carbons right there. Okay, as we said earlier, this actually has 4 carbons in it. 1, 2, 3, 4. That is butane. We haven't designated where the triple bond is yet. So, if that's number 1, this would be 2, 3, 4. We can count it from the other side the same way, right? 1, 2, 3, 4. It doesn't really matter. They're the same both ways. So we just simply say that that's 2-butane. Okay. This next one, go to the top here. This next one gets a little bit more complicated. So let's count how many carbons we have. We obviously have a double bond here, so it's going to be an ene. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's going to be an octene. Now we need to tell people where the ene bond is located. If I count from this direction, it's 1, 2, 3, 4. So 4 is our lowest number. It's between the 4th and the 5th. 4 is our lowest number, and we put 4-octene. Now let's count from the other side and just make sure that we had the lowest number possible. 1, 2, 3, 4. It's also the same, so it doesn't really matter in this case. Now, here's the addition. We have to also tell people if this is cis or trans. That goes in the front of the word, and we typically write that in italics if possible. So since our carbons are going opposite directions, we're going to designate that as a trans for octene. Okay, let's go back to an alkyne. You can see this side is going to get us to our triple bond the fastest. So we're going to label this again. 1, 2, 3, 4, 5, 6. So this becomes 1, 2 is the lowest number. 2 hexyne. Okay. I'm going to again start by counting our carbons here. 1, 2, 3, 4, 5, 6, 7. We want to count this direction because it gets us to that double bond fastest. So it's going to be a 2-heptene, and we designate it as a cis because the carbons are going in the same direction there. Yes, that can get more complicated. Let's not do that just yet. Okay, now in this case we have another issue. We've now got a substituent coming off of there. If I don't worry about that substituent, realize that your ene bond could be either 1, 2, 3, 4. We can count from this direction. 1, 2, 3, 4. Well, since you have a substituent here and you want him to have the lowest number possible, then we're going to number from this direction. Also realize that these are going trans. That alkene bond are going in opposite directions. So that is a trans. 1 fluoro, 2 butene. So I ended up counting 1, 2, 3, 4. Okay, good. Hopefully we can see that this is a bromocyclohexene. The numbering might be getting you a little bit off, but hopefully not. So we want to list this as a 1, 2. We can either list this as 1, 2, 3, 4, 5, 6, or we can list it as 1, 2, 3, 4, 5, 6. That would put bromine pretty low. We do not start by numbering bromine because the alkene is going to take priority in numbering. So we're actually going to go ahead and say this is 1, 2, 3. Since the ene bond, or the double bond, is assumed to be between the first and the second carbon in that ring, we don't need to designate that, but you're welcome to. So this would simply be 1, 2, 3, was where the bromine is located. So it's 3-bromocyclohexene. Okay. In this case, we have a triple bond here again. 1, 2, 3, 4, 5, 6. Okay. So this is going to be easier to name from this side, excuse me, because that will make this substituent a lower number possible. So I'm going to name this 2-iodo-3-hexene. So 1, 2, and then that's going to be your 3. Okay. Last example here, I'm just going to make up on the spot because I realized that I want to make sure that you all realize something here. Okay. 1, 2, 3, 4, 5, 6. We've got a hexene, but now you might wonder, which way do we actually number that? Well, the ene is going to take precedence. Things that change the end of the word usually take precedence when it comes to numbering. So I'm going to say that this is 1, 2, 3, 4, 5, 6, and it becomes 5 fluoro 2 hexene. But we can't forget this is still trans, so we need to designate that as well. Now sometimes you'll see the trans in parentheses. Don't get confused, it means the exact same thing. Thank you very much.